Hello, Happy New Year. Welcome to 2021. We are finished with 2020 finally. My name is Chris Traley. I will be teaching CS 371 this spring. Welcome also to CS 371. This is a course that everyone in the major passes through at some point. So it's a really good opportunity to touch base and go over some topics that are important through all of CS. I'm also hoping to have it be a checkpoint for career preparedness. So I have a few activities that will help us to prepare for job applications and also grad school applications. Furthermore, I hope that this will be an opportunity for us to build a community since everyone has to pass through this course. So I've tried to build activities into this class that will help us all to get to know each other a little better. To that end, let me first introduce myself a little more, and I'll be asking you for some details about yourself. But for those of you who don't know me, you are having me for the first time, again, my name is Chris Traley. This is my fourth semester at Ursinus. I started in August 2019. I am a tenure track professor in computer science, although I cross over to math quite a bit as well, so I'm really kind of in between the two. I did my undergraduate, first of all, I did high school right around the corner in Montgomery County, Upper Dublin class of 2007. If you Google me in Upper Dublin, you'll probably find some stuff. You'll probably find some old embarrassing pictures of me. So do that if you feel like it, I guess. So I did my undergrad at Princeton, graduated 2011. Those were good times for sure. Then I moved on to Duke University, where I did my master's and then my PhD in electrical engineering. Graduated spring 2017. Also met my future partner, and we got married at the Baltimore Zoo. She was finishing her PhD at Johns Hopkins in Baltimore. So fun fact. Then we recently, so the pandemic was crazy, so we were kind of living apart, but then we came back together. And we are now living together in Philadelphia. We just got a new dog, Theo. And then we have our cat, Layla, who's with us, and our cat, Darcy, who sadly did not survive the pandemic. But anyway, so we got our nice family with our animals. And, that's pretty much my personal life, I guess. In terms of my work life, outside of teaching, I do research on multimedia data processing and topological and geometric data analysis. So I do some weird stuff where I turn videos into topological shapes, and I turn music into geometric and topological shapes and come up with new shapes. And I do some of that with students as well. So that's sort of my job in a nutshell. Okay, so what I would like to do now is to run through briefly the topics that we're going through in the course, just so you have a sneak preview of the course content. There will be 6 units in the course. Each unit will have an assignment that it culminates in. And there will be a final project at the end or a final assessment, which I'll talk about in a moment. So Unit 1 is going to be Intro to Python, Abstract Data Types, and Empirical Complexity. So this is what we're going to be doing at the beginning. I'm going to bring some Pythons into class, and you're going to be learning Python. That's, obviously. Okay, so Python's a programming language, if you hadn't heard of it. It's become very popular in recent years. Because everybody passes through 371, it's a nice opportunity to make sure that all Ursinus undergraduates, majors in CS, leave with some Python knowledge, in addition to Java and C++, which you'll learn in 173 and 174. It's probably one of the most widely used languages. I think it's probably more used and more valued in industry than Java and C++. It's also a higher level language, so you don't have to worry about memory management. It's pretty loosely typed. These things are all very nice, and they allow us to write more efficient code, but there are some pitfalls, so we'll be careful as we go along. And this is also the reason we want you to learn more pedantic languages first. Okay, so here's another take on the whole Python situation. Maybe there's going to be some Pythons in the class with us. Okay, introductory Python programming course. So we'll spend, I'm not going to spend like too much time teaching Python, because once you learn a couple languages, learning a new one isn't that big of a deal, because you already know all the programming paradigms like if, control statements, loops, methods, classes. But we will spend the first week doing majority Python exercises, and then we'll transition into doing more algorithm stuff, and we'll kind of learn more Python as we go. But in the first unit, we're also going to be looking at, as I said, empirical complexity. So we're going to start to measure how long it takes programs to run, and we're going to learn how to do that in Python. So by empirical, I mean experimental. So there are mathematical tools that we're going to use to analyze programs as well, but we're going to start off just by experimenting. And we'll also define what an abstract data type is, and certainly in my version of 174 we talked about this, but I'll go over it again for everyone, and it'll be a good review, even for those who have seen it. And we're going to see our first real algorithm that you probably haven't seen before. It's something called union find. And we're going to be working on it actually at midweek next week already, the second week of class. So it'll culminate in an assignment that is on detecting the locations of cells in an image of plant cells. So that should be pretty interesting. And you'll be able to do that very efficiently. Okay, so in the second unit, we're going to get a little more rigorous. So we're going to learn some mathematical tools to analyze how long our algorithms take to run and how much space they use as they're running. In the process, we're going to really talk about some problems of search. We're going to dig into a bunch of different ways to search through a collection of objects efficiently. And one of the really important data structures that we're going to go over is something called a hash table. And of course, my 174 students who have me are quite familiar with this, because I think hash tables are extremely important. As it turns out, I believe that a lot of recruiters agree with me, so it'll be good to see it multiple times, even if you've seen it before. But there are many other data structures that we'll look at in this section. And we're going to use a different data structure actually for the main assignment in this unit, which is on doing autocomplete. So you will implement an autocomplete system, give it a big dictionary of words and a dictionary of locations. You will create an efficient program to look for similar things to complete what you're typing. All right, so that's Unit 2. Unit 3, we're going to talk about recursion and how we can use recursion to design efficient algorithms. We'll go over two strategies. One of them is called divide and conquer. Another one is called dynamic programming or memoization. And we'll get to look at all sorts of cool problems, like how do you draw these fractals? They're called fractals. Just with a very small amount of code. How do you solve this thing called the Towers of Hanoi? How do you solve this so-called knapsack problem, which is you have a bunch of different objects that are each different sizes, and they are each worth a certain amount, and you want to maximize the amount of value that you carry in your knapsack, which only has a certain capacity. And we're also going to look at problems of matching strings, DNA sequences, and even audio sequences. And the audio part is what our assignment's going to be about. So let's listen and hear what the problem is that we're going to be addressing in the assignment in this unit.
Fourscore and seven years ago, our fathers brought forth on this continent a new nation, conceived in liberty, and dedicated to the proposition that all men are created equal.
And dedicated to the proposition that all men are created equal.
Okay, so those were two dramatic readings of the Gettysburg Address, but they were not aligned, right? The people who were saying each one were talking at a different rate. So what we can do actually is create a program to automatically align them so that they are synchronized in a way, so that they line up.
87 years ago, our fathers brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men are created equal.
All right. So you'll get to do that, and it's actually not as difficult as you might imagine once you have the right tools. So that'll be the climax of the third unit there. All right, so that's about the halfway point. Then we're going to move into sorting, selection, and shuffling. And people often start with sorting in an algorithms course, but I think it makes sense to go through some other strategies first. We'll get to go a little deeper here with this stuff. And we'll even talk about elections a little bit, these so-called rank aggregation techniques. And we'll use some of the techniques that we learned for aggregating ranks to kind of have different classifiers of 3D shapes vote on what their matches are. Okay, so we're going to make something that you could colloquially refer to as shape Google. So given a 3D shape, find me all bunch of shapes in a database that are similar to this shape. So here's like a 3D chair, and here's all the chairs that are found that are similar. Although they're not all correct. You can see that this one is actually not a chair, it's a phone. But the idea is if you do some of these tricks with sorting and ranking, you may be able to use multiple different votes to do a better job. Okay. All right, so that's unit 4, but we'll talk a lot about sorting too. Okay. Unit 5 is where we get into some really fancy data structures with trees. And we're going to talk about all sorts of different kind of trees. The star of the show is going to be something called a binary search tree. We're also going to go over binary heaps, Huffman trees, and something called a trie, T-R-I-E. And these all have different applications that are quite neat. The assignment in this section is going to be to learn something called a phylogenetic tree. So given DNA sequences for different species, you're going to be able to match the DNA sequences, actually using some algorithms from Unit 3. So not altogether different from matching the audio. But on top of that, you're going to use the similarities that you compute between the DNA to create this tree, where things that are similar are grouped together. So you can say human and Neanderthal are quite similar, really almost exactly the same. And those two group together with chimp. Chimp turns out to be our closest cousin among living primates. And we can see this with the DNA. So this tree kind of makes sense, and we're going to learn it from data, and you'll build it in the assignment. Okay, the last unit is the most advanced unit, but also unlocks some really cool applications, and this is graphs. So a graph is like the next step beyond a tree. And we're going to talk about depth first search, breadth first search, Dijkstra's algorithm, Bellman-Ford, Floyd-Fulkerson, all sorts of classic algorithms for graphs. Min cuts. Okay. So minimum spanning trees. All right. And one of my favorite topics in graph search is something called A-star search. And it's a really nice trick for getting algorithms that don't necessarily provably run efficiently to, in practice, run efficiently. So there's something called the rush hour problem, where you have to get a red car out of a parking lot. And it was like a board game, that classic board game. And if you look at this one, this looks like kind of a nightmare, right? Let's say you're the red car and you're here and you're trying to get to the exit. How are you going to do that? It looks like a nightmare, right? So we're going to create programs to automatically solve that. And you will come up with ways of doing it better and better, and we'll actually have a little competition in the class to see who can solve it the fastest. So that'll be fun. All right. So that's all the content for the course. We're going to cover quite a bit, but some of it is a review from 174. And it all kind of fits together nicely. So I'm really looking forward to it. This is a good set of core computer science topics that we're touching on. All right, so I do now want to jump to the course webpage to talk about some logistics, and then I'll have you continue on and do a couple tasks to get warmed up. So first of all, here's the course webpage. You should really familiarize yourself with this, because basically all the information for the course is going to be here. Now, you should take some time to read through the landing page here, which really is the syllabus. So this is where I talk about, we're going to meet Monday, Wednesday, Friday, 1:30 to 2:20. We're going to figure out the office hours soon, but I'll have all that. The fact that this course is occurring as a hybrid course, so what that means is I think most students will show up in person to this dance studio so we can be socially distanced, because rather large class, about 26 students. But some students will be remote. So what it means is everybody needs to have a laptop and headphones, because we're all going to be plugged into Zoom, even those of us who are in person. And I want to do this because last semester I taught remotely, so I didn't really deal with this myself as much, but I saw there were some surveys taken at our science that showed that students who are remote really appreciate it even when the students in class are on Zoom. It makes them feel less isolated. Otherwise, the remote students end up being left out. So for the sake of our community, let's please do that and all log into Zoom and have our cameras on at all times. That's also very important. That will factor into your attendance score. So I do expect you to have your camera on and to be present. Of course, if there's a reason that you can't have your camera, we can speak about that, particularly if it's related to accommodations. But otherwise, I'm assuming that everyone will have their camera on and will be connected to Zoom. Okay. There I am, I guess slightly younger. Might need to take a new picture soon, although I guess I'm holding up. All right, so you could read about the course description, what I say about algorithms. I tried to bold the key things that I think stand out in this course. So we're trying to look for programs that are provably correct. So we've got a problem you want to solve. How do we know that this recipe that we came up actually solves it? So we're going to be trying to focus on that, proving that things are correct. Analyzing efficiency, which I touched on in my little overview, so we can do that experimentally, but we're going to also really focus on mathematical tools to analyze the efficiency of algorithms. And then we're gonna really look at data structure. So it's not just the set of steps that you follow. It's also very important in the background. How do you store the information that you're manipulating as you solve those problems? And think of it like a pairing of wine and cheese. Like the wine is your algorithm and the cheese is the data structure. We're looking for good pairings. I'm not really classy enough to know good wine cheese pairings, but that's sort of an analogy you can think of. And hopefully, if you get a good pairing, it'll lead to an efficient and elegant implementation. Okay, so that's the idea. Those are the core ideas in this course. So you can read through the learning goals and the learning objectives. These are central to all the things that I've designed in the course. Okay, now just to point out, there is a zoo of technologies we'll be using, but I think once you get used to it, it won't be too bad. So first of all, there's a class website. Here we are. Check. Really what's happening here is, of course, there's a syllabus, but also pay close attention to the schedule. So you go over to this menu here, you click on the schedule. This lays out all the topics that we're going to be going through and the dates that we're going through them. And the right panel is also due dates for different assignments. You'll notice that the first module, the one you're on now, is due on Wednesday. I'd like you to finish the syllabus quiz before class, and you can finish the rest by Wednesday evening. I'm going to update the description of each unit a little more later and flesh out some more of the deadlines, but all the topics are here now, and I'm pretty set on those topics. So stay tuned for updates. You should always refresh this and have a look. Sometimes I'll put just fun resources here, like this link on how only 10% of expert programmers correctly implement binary search. A couple students in this class who had me in 174 might remember that I screwed up binary search. so I'll definitely talk about that again. And just maybe some XKCD jokes like bread first search. Okay. So just to lighten things up a little bit, but also some important materials as well. Okay, so that's a class website. Canvas really is a skeleton for this course. I'm not a huge fan of Canvas. I really like to customize things on my own. But it is a good platform for storing submissions for assignments and for me to provide feedback. So that's what I do. So you'll submit all of your assignments on Canvas. I will provide my feedback there. And all the grades will be stored on Canvas. So that's pretty much it for Canvas. You're not really going to find anything in detail about the course there. Zoom. Okay, so as I said, we're going to be meeting over Zoom during class, and that's all we're going to use Zoom for. Actually, Discord is another very important component of the course. So for those of you who don't know, Discord is a little chat platform which was developed for gamers, but we found last semester during the pandemic that it was quite nice for computer science classes as well. So it's much more laid back and casual than Microsoft Teams, but has basically all the same features. And so it's very easy to start chats and to ask questions to the whole class. Sometimes to share random topics that are interesting and related. They've also got some nice live chat rooms. So people last semester found that sometimes they would have little mini hackathons to work on the assignments together on Discord. So that's great. The one change I'm making this semester is I'm also going to use Discord for office hours. So there's a Discord channel for the ACM club, which is our computer club, that we're going to use for office hours. The regular Discord for CS371 we're going to use for questions about the course, and we're also going to have it open. This is another little change from last semester. We're going to have it open during class. So we have Zoom and Discord open. The reason is I wasn't very happy. Zoom is good for breakout rooms and things like that, but I wasn't super happy with all of the polling that Zoom had. So we're going to do some polls and other things like that over Discord. So we'll try to have most of our chats over Discord. So students will send texts during class over Discord instead. So we'll start off and see how that goes. Teams is still something we'll use as well. I'm sure most of you are familiar with that by now. Mainly Teams is something I would encourage you to use to work with your buddies. So a buddy is a partner on an assignment that you're allowed to actually share code with, not send code, but sort of share your screen as you're working. It's also where I would like you to communicate with me for things of a more sensitive nature. So don't send me messages over Discord, even direct messages about grades or personal issues, because Discord is a third-party platform. We really like to keep those things locked down under assign as sanctioned things like Teams. Okay, so Teams is basically going to be just for chatting. Sensitive things with me or with your partners, you can set up video chats. And finally, email is kind of a last resort. I'm not a big email person, but if you'd like to email me about personal issues or other things, you can do that. I will also put announcements over email, but the announcements will also be duplicated over Discord. Okay, so I'll always have the announcements in two places so you won't miss anything, and they'll be on the schedule. So as long as you check the schedule, email, and or Discord, you will always be aware of what's going on in the course. So you don't have to check all of them, as long as you check at least one of them. Okay, so I've already kind of explained how Zoom is going to work. Of course, social distancing is important. I've explained how Discord is going to work, how we have two channels. One of them is just the general channel for the class, but the other one is our ACM Computer Club Discord, which I will have my office hours in. Because office hours are for everybody, not just 371. Okay, so here's another thing. So readings. The textbook is free. Yay! So it turns out somebody I know actually wrote a textbook that is perfect for this course. It's called A First Course on Data Structures in Python, which I think is selling it short. This is kind of a dry title for actually how good this book is. Very good book. Because we're reviewing a bit from 174, I will go slightly beyond this book, but this covers most of what we need. This week, I would like you to start reading Chapter 2 and Chapter 3, because that's going through the Python stuff that you need. And then we'll move on to more algorithm stuff. Yeah, this book, I was totally relieved to find this because I thought I was going to have to write my own book. That saves me a lot of time. Okay, so now on to how am I going to assess you in the course? How am I going to assess your learning? Well, the first thing is these pre-class modules. Many people have had me before and they'll be familiar with these. This is something that I started during the pandemic last spring, but actually found worked quite well and had overwhelmingly positive reception from students. So the way it works is, I'll show you an example from last spring in 174, or sorry, last fall. I'll show a little video. So these little web pages, I show a video. I have some comments on the video, some notes for you. Videos, I try to keep them short, like 10, 15 minutes. Then you hit next, and based on what you just did in the video, I want you to edit some code, and actually live in the browser you can check to see if it works. So you put in your NetID. This was C++, you actually had to compile first. And if you run and it doesn't get it right, it'll tell you maybe a hint based on what you did. And once you get it right, it automatically sends you an email, it sends me an email with your correct solution, and it also gives you credit on Canvas. And then you just keep going, then there's another video. So would like to, in this course, have 2 to 3 of these per week. And they're now worth 15% of the grade. In the past, they were only worth 10%. But yeah, these will really make it so that when we get into class, we can have deeper discussions about the topics. So I quite like these, and they've worked out really well. But the bulk of the grade will actually be from programming assignments. So as I said, there will be a programming assignment for every unit, 6 total, each worth 10% of your final grade. And they'll all be in Python. Another thing I'm going to do is what I call here a pre-class algorithm design. One of the things I felt like I was missing personally when I took algorithms was, yes, I learned a lot of algorithms. I was able to implement them. I was able to apply them. But one thing I felt that I didn't learn was how to design new algorithms from scratch. And it wasn't until I started researching this topic that I realized how deficient I was in this area. I think this is something that people forget to teach in algorithms. And one of the things I learned is that this actually really takes time. Algorithms, even if the problem statement is simple, and even if the final solution seems simple, you'll gain an appreciation for how much time and effort it takes to design them when you try to do it yourself. So it's very different. You sort of can get the wrong idea by reading an algorithms textbook, because they throw all these algorithms at you. It's like, oh yeah, okay, I see how that works. And you don't realize how much time it took people to come up with these ideas. A lot of these things are not obvious at all. So I'd like you to spend a little bit of time actually trying to come up with some of these algorithms on your own before I give away the spoilers. We'll do some of that in class, in groups. But for this pre-class algorithm design, I'd like every student, for one unit in the class, to think about one of the algorithms we're going to go over later without looking online or at any resources, and see if you can solve it. And you'll have a week to do it, and I'll check in with you halfway through to see where you are, and to give you some hints maybe, and to give you some feedback. And then we'll go over in class what the solutions are that people came up with, and also the solution that I'll present you, which maybe is from the textbook or another place. So I'll basically pick one class every unit for an algorithm like that. And if you happen to be up that unit for your pre-class algorithm design, then it'll be your job to try to think about that algorithm to solve it, and even to write a little bit of code to implement your idea. So again, I want to stress that this is a process. I think we do a big disservice to people in the community who are learning by signaling intentionally or often unintentionally that algorithms are either easy or you don't get it. But really what it is, I think algorithms is a tough subject. I'll just tell you personally, it's not a subject that came naturally to me. It definitely took some time. And I want you to take your time in this class. And I think if you do, you'll find it very rewarding. So that's why I'm doing that. Okay, now the last thing is the final assessment. I'm not a huge fan of traditional pen and paper final exams. But this is an opportunity for us to come up with a summative assessment of everything we've learned in the course, because it all does fit together. But I want to give you a little bit of autonomy in choosing how to do the final assessment. So there are 2 options. One of them is a mock coding interview. So as you may or may not be aware, one of the most important components of a software engineering interview in the modern day is this coding interview where they actually, either over Skype or in person, will give you a problem to solve. Really, in the spirit of this class, it's usually an algorithms problem. And they'll tell you to code up a solution to the problem. And they'll watch you as you do it live, which is very nerve-wracking. So you can take this final as an opportunity to practice that. So I will interview you and give you a problem that is on par with problems that you may see in an interview. You should have all the skills by then, of course, to tackle those interviews, but it will take some practice. The other option, which I personally would have chosen if I were in your shoes, is something totally different, more like a final project. So rather than an oral exam, it's actually going to be a project where you implement an algorithm and you make a skit about it. So there's a conference called the Symposium on Computational Geometry, or SOCG for short. And it's about algorithms that are geometric in nature. So we're going to be learning a lot of algorithms in this class. There's an area called computational geometry, which is specifically focused on algorithms that deal with shape. And every year, this conference on computational geometry has a multimedia expo, which is where people make skits or web apps or things like that to show an algorithm that they think is neat, or that they think they could explain in a better way than it's traditionally been explained in the literature. So I have some examples here of skits that people have done recently in this conference for different algorithms. You can watch them. And I have a bunch of ideas of things that you could do, different topics that you could talk about. I'll just a side note, for those who had me in computer graphics, you may be particularly interested in this, in either alpha shapes or this Hamiltonian path. So this is a really cool algorithm you can implement to draw this, like, almost looks like a space filling curve, like wireframe, basically tracing the surface of a 3D shape without lifting your pen and without crossing yourself, and then eventually ending up back where you started. It's something called a Hamiltonian cycle. This is a really cool project, so I hope somebody does this one, at least. But they're all cool, of course. So I have a bunch of ideas, and I'm happy to discuss them more. The upshot is, if you choose this option, we may be able to publish. So we may actually submit to this conference, and you may get to go to the conference, and I would certainly pay for that. So that's something to think about. This is a good option for people who want to go to grad school or who are trying to build their portfolio. But the mock coding interviews will also certainly be very useful. So this is what I mean about career building in this class. So I hope either way you'll walk away with something that helps you be stronger on the job market. Okay, so that's pretty much it. And here's the breakdown of those different activities. I have a lateness policy here. The upshot is, if you communicate with me ahead of time, I've never not granted an extension. But if you don't communicate with me, I will have to add some penalties to your submission. All right. I have some stuff about inclusive environment. The fact that CS has not always been a very inclusive discipline, and how we're trying to do better. I'll see if I can find some opportunities in class to talk about ethics and algorithms and things like that. But regardless, we're being mindful of the fact that we are cultivating a respectful classroom where everyone's opinion is valued, and that everybody brings something different to the table. And I certainly value everyone. I always say, my mantra is, everybody is special and nobody's special. I usually say it the other way around. Nobody's special, which means that everybody's special to me. So that's a corollary. Okay. So you all belong in CS, and it's a pleasure to be able to teach you. So I want you to feel comfortable as a learner, and comfortable enough with me and your classmates so that you can feel uncomfortable pushing yourself with your knowledge and your CS abilities, okay? So we need to be comfortable as a learner in order to be uncomfortable with the conceptual stuff. Because research shows that we need to be able to be uncomfortable when we think like smoke coming out of your ears as you're thinking about things. That's sort of the vision I have You need to push yourself in that way to learn. Okay, but you can't do that if you can't get past the initial comfort boundaries. That's why the inclusive environment is so important. Okay, so I talk a little bit about the participation score. Basically, show up to class, participate in good faith, you'll be fine. Sometimes I'll have a few pre-class exercises for you to do, and I'll cold call on somebody to make sure that you did it, and that will factor into your participation score. Okay, so some common sense rules about online communication, which we call netiquette. And the last thing I want to point out is just the collaboration policy. So as I mentioned before, on the programming assignments, you are allowed to have a buddy, or even two buddies. So you can work in groups of 3 if you'd like, although 2 is probably a little easier to manage. And in the buddy capacity, you can really work quite closely, and you can even share code with each other, but I do not want you to send code electronically. So what that means is you should never send the text of your code to anyone. You can briefly flash some of your code as a screen share, but I don't want anybody to be taking screenshots or keeping up there for too long. The idea is, as you're helping each other, it is good and very productive in a group if you can look at each other's code and help each other debug. But I really want you to come up, after that happens, sort of walk away and come up with your own solution. Make sure that you can actually replicate everything on your own without looking at somebody else's code. So that's the idea. And I'm trying to find a happy medium between 2 tensions. One of them is, well, in the real workplace, you are going to be very collaborative. You're going to be using other people's code. You're going to be working on the same code base with people. On the other hand, we're still working on fundamentals here, so we want to make sure that every student can master the fundamentals. And if you're ever unsure about whether a modality of collaboration is acceptable by me, just talk to me, ask me a question. We can talk about these things. What I don't want to see is I think there's some pretty obvious violations. Like, again, don't let me discover that you've sent somebody else your code. That's a no-no, and I will have to report that to the dean. And just remember, the whole time that your reputation is much more important than your grades. To all of us, this is something I think we don't stress enough, but we write stronger recommendations for students who have lower grades but who work very hard than we do for students who have higher grades but who have cheated. So just keep that in mind. This takes a lot of time away. If you cheat, it really is a huge pain. I do take it personally. It really hurts my feelings because I put a lot of effort into this stuff. So, I know people get desperate and they do that, but if you feel desperate, just talk to me. That's all I'm asking. And we can get you through, okay? So, but you are allowed to collaborate with a buddy. Just let me know who the buddy is when you submit, and be mindful of this table here. So this tells you all the things you're allowed to do. Okay. So that's sort of the riot act. I don't like being a disciplinarian, but I've had to do it at Ursinus. So don't make me do it. Okay, that's all I'm going to say about that. Okay, and there's some more stuff here about official accommodations, tutoring if you need it, some stuff about mental health. I'll point out that I'm somebody who has struggled with mental health things, and I would highly encourage you to get help, because help in the form of psychotherapy and medication has been extremely helpful to me in the past. So if you find yourself going through that, please seek help. Don't be afraid to talk to me about it. I'm not an expert, but I can certainly model what it's like to be somebody who works through these things and who is able to be productive and have a good, happy life in the end. Okay, so that's pretty much it. I'm going to have you walk through a few more things. Before class on Wednesday, I'd like you to finish the syllabus quiz at least, and then by the end of the day, I'd like you to finish the rest of the software configuration things. Thank you for your attention. This video is certainly much longer than most of the videos I'll make in this class, but that's the way it is with the syllabus. When we're in class on Wednesday, we'll spend a little more time just shooting the breeze, answering questions about the syllabus, and maybe just playing a little puzzle that will sort of motivate some of the things we're doing in this class. All right, I'm really looking forward to seeing you on Wednesday. I'm looking forward to getting to know all of you better. See you soon.